Hi students, today we will discuss trends in the modern periodic table. So in trends in modern periodic table, we will see first valency. So what is valency? It is the combining capacity of an element. So in this there will be number of valency electrons in the outermost shell of the atom is its valency. So we will see in this the outermost shell will have free electrons. They are called valency electrons. So how many free electrons are there? That is its valency. And next they gave atomic size, how it will change. What is atomic size? It is the radius of an atom. So radius means from the distance from the center to the distance from the center means nucleus to the outermost shell is its radius, and it is the atomic size. We will see here atomic size. The atomic radius of hydrogen is given as 36 pm, means 1 picometer means 10 to the power of minus 12 meters. And we will see how the atomic radius in from left to right means along a period, and also along a group. We will see along a period. So from left to right, if we see, there will be increase in the nuclear charge, means so the nuclear charge will affect more on the outermost shell, and it will pull towards it. So when it pulls towards it, the atom will shrink and it will be small in size. It will be decrease its size. So along a period, atomic size will decrease. Then so here we can see that only this is due to increase in nuclear charge, which tends to pull the electrons closer to the nucleus. So there will be reduce in the size of the atom. Then what happens along a group, down the group, what happens when many new shells will be added. So in the first one only one shell, K shell. After that more shells will be added, K, L, M, N. Like this more shells are added. So when the more shells are added, what happens? There will be increase in the distance from the nucleus to the outermost shell. There will be more distance. So in spite of increase of the nuclear charge also, because of the more distance, there will be increase in the atomic size. So the distance between the outermost electrons and the nucleus will be increased. So the atomic size increases in spite of the increase in the nuclear charge. Like this we can see the atomic size in the period it decreases, in the group it increases. Next we will see metallic and non-metallic properties, how it will vary. So as we can see, metals like sodium and magnesium are towards left hand side. We'll see here sodium, magnesium in the left hand side, and in the right hand side we can see sulfur and chlorine. Sulfur and chlorine. Sulfur and chlorine, we can see these are inert gases. So sulfur and chlorine we can see right hand side, and the left hand side sodium and magnesium. Means in the middle we have silicon. So in the middle we can see silicon. In the middle we can see silicon. In the middle we can see silicon. So it is whether it is not a metal or non-metal. It is a semi-metal or metalloid it is called, because it exhibits both the properties of metals and non-metals. In the modern periodic table, a zigzag line separates metals from non-metals. What are that zigzag metals? The borderline elements like boron, silicon, germanium, arsenic, antimony, tellurium and polonium are intermediate in properties, and they are called metalloids. See the border elements, boron, silicon. See here they gave in pink color, boron, silicon, germanium, arsenic, tellurium, polonium. So these like zigzag line, this will separate the metals and non-metals, and they are called metalloids or semi-metals. We also know that metals will lose electrons by forming bonds, and so they are electropositive. So if they lose electrons, they will have electropositive in nature, and if they gain electrons, then they will become electronegative. So So we know that metals will tend to lose electrons to form bonds. So when they lose electrons, they have electropositive in nature. So and what happens? So the nuclear charge on the valence shell electrons increases across a period. We told here there will be a more nuclear charge. That's why the size increases. Size decreases. I told no. So here effective nuclear charge will be more across a period, so that the tendency to lose electrons will decrease. So along a period, tendency to lose electrons will decrease. So but down a group, more shells are added. So along a group there will be increase in the shells. So if there is increase in the shells, then the nuclear charge will be less because the distance will be more. So it will easily lose the electrons. So in a group there will be tendency to lose electrons will increase. So therefore, hence metallic character decreases across a period. So the metallic characters will decrease along a period, and in a group it will increase. And non-metals on the other hand are electronegative. What are electronegative? If it gains electrons, it is electronegative. So metals are electropositive because I was already told metals will lose electrons, so they are electropositive in nature. And non-metals are electronegative because they gain electrons. So like this we can see the variations. So as the trends in electronegativity show, non-metals are found on the right hand side. So because like this there will be change in the gaining and losing of electrons, we can see there will be change in the characteristics. The non-metals are found in the right hand side and metals are found in the left hand side. It also shows the properties to formation of nature of oxides formed by the elements. We can see that oxides of elements are basic. So metals are forming basic and non-metals are generally acidic in nature.